Welcome to this explainer. I am absolutely thrilled to have you here today. Okay, let's just dive right into this. Because if you're preparing for your Cambridge mathematics examinations, and I'm talking specifically about syllabus codes 0580, 0606, 4024, 4037, or 4040, you already know the pressure is on. You can feel the clock ticking. But today, we are going to look at this from an entirely different angle. We are using the game designer strategy. We are going to master something that trips up thousands of students every single year, and that is set theory. We are going to look at mathematical set notation not as some confusing, intimidating jumble of abstract symbols, but as a secret, incredibly logical language. Think of it as a tool that perfectly translates complex, overwhelming word problems into very simple, beautiful visual puzzles. Every paragraph in an exam question is a puzzle piece, and each one unlocks new insights. You see, I look at past papers all the time, and I constantly see two types of students. Let's call them Alex and Sam. When Alex sees a set theory question, he just goes into full panic mode. He overloads his answers with raw mathematical facts, but provides absolutely no structural analysis. He just throws every number he can think of at the page, hoping something sticks. No structure, no logic. Sam, on the other hand, Sam rushes. Sam completely misses the specific requirements of the mathematical command words and symbols. He doesn't decode the question, which costs him so many easy marks. Today, we are going to fix both of those flaws. We are going to level up your answers, give you the ultimate exam strategy, and boost your mark potential from 0 all the way to 100%.
Here is our roadmap for this explainer. If you've ever felt completely lost staring at U-shapes, squiggly brackets, and intersecting circles, you are in exactly the right place. First, we are going to build your knowledge from the absolute basic vocabulary. Then, we'll move into groups and subsets. Third, we will introduce the visual grammar of Venn diagrams. And finally, we will use our new skills to crack a highly complex algebraic mystery that you might find on your actual exam paper. Along the way, I'll be teaching you a proven system, including how to decode command words and apply a structured framework to guarantee your marks.
All right, let's get into Section 1, the language of sets, learning the vocabulary. We absolutely cannot write a top-tier answer if we don't know the words, right? So let's start with the absolute foundation. If you want to think like the game designer who wrote your exam, you need to speak their language.
What actually is a set? Well, in mathematics, a set is a well-defined group of objects or symbols. And we call those individual objects or symbols the elements of the set. It's simply an organized collection. Take a look at this example: South Africa, Namibia, Egypt, Angola. It is incredibly clear what this set is representing. The elements of this set are countries in Africa. Because there is a specific, countable number of countries in Africa, we call this a finite set. If I asked you to add 2 more elements, you could easily say Zimbabwe and Ghana, and you'd be perfectly correct. But keep in mind, sets can also be infinite. For example, if our set was all the natural numbers, 1, 2, 3, 4, continuing on forever into infinity, that's an infinite set. Sets can even be coordinates on a straight line. The beauty here is that as long as the mathematical rule is clear, anything can be a set. Now, before we continue and look at how to actually write these sets down mathematically, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, so this brilliantly illustrates our very first piece of mathematical vocabulary. These symbols are your command words. You see that little curved E shape on the left? That is the element symbol. It is just mathematical shorthand for belongs to. So when you see a lowercase e, then that curved symbol, and then a capital S, it simply reads as the element E belongs to set S. If we go back to our Africa example, we could write Egypt, then the element symbol, then Africa. Egypt belongs to the set of African countries. Now look at the other symbol on the right. We have the exact same shape, but with a firm diagonal strike right through it. Just like a no smoking sign, the strike literally means does not. So that notation translates perfectly to the element E does not belong to set S. For instance, France does not belong to the set of African countries. It really is just reading a sentence. Students like Sam miss this because they rush. They don't pause to decode the symbols.
Now here is our master translation dictionary. I want you to literally take a mental picture of this right now. If you were taking notes, write this table down. This is the command word decoding system that top students use, and the one that struggling students entirely miss. We already covered the first two, belongs to and does not belong to. The third symbol, that circle with the diagonal slash, is the empty set. It means a set with absolutely nothing in it, 0 elements. It's totally blank. The fourth symbol, the upside-down U, is the intersection. Think of it like a physical road intersection. It's where two streets overlap. In math, it represents the elements that belong to both sets at the exact same time. And finally, the right side up U is the union. The union is the ultimate team-up. It includes everything that is in either set or both sets combined. If you know these 5 symbols, you can decode any set notation problem the Cambridge examiners throw at you. In fact, let's introduce a concept here, the Peel framework. Normally it's for essays, but we adapt it for math. Point, evidence, explanation, link. Your point is identifying the command symbol. Your evidence is pulling the right numbers from the question based on that symbol. Your explanation is showing you're working out, and your link is writing the final set notation perfectly.
Let's move to our next section, subsets and universal sets, groups within groups. We are going to see how this logic builds when we start looking at smaller sets living inside of larger ones.
A subset, written with that elongated sideways U with a line under it, means that all the elements of one set, let's call it X, are also elements of another set Y. So the crucial point is that a subset is just a specific, smaller category that fits perfectly inside a broader category. For example, if set Y is all fruits in the world, then set X, apples, is a subset of Y. Every apple is a fruit. The math notation just makes it formal. And here is a golden rule that game designer examiners absolutely love to test, and it catches out students like Alex all the time. The empty set is considered a subset of all sets. I know it sounds a bit weird, but even a group of literally nothing mathematically fits perfectly inside a group of something.
To truly bring this to life and lock it into your memory, let's imagine a group of 3 friends. We have Winnie, Natalie, and Emma. Together, they form set A. How many different smaller subgroups or subsets can they form from this trio? Well, let's apply our structural analysis. First, all 3 of them hanging out together is technically a subset. Then, Winnie and Natalie can pair up without Emma. That's a subset. Emma could just be hanging out on her own. That's a subset. And, as we just learned with our golden rule, the empty set, meaning none of them show up, is also a perfectly valid mathematical subset. Whenever you are asked to list subsets in a Cambridge exam, do not be like Alex and just throw names on the page randomly. Use structure. Always remember to systematically break down the group, start from the whole group, then move to the pairs, then to the individuals, all the way down to the empty set.
Now, every single problem you will ever face in mathematics has its boundaries. We call this boundary the universal set, represented by a slightly different, more rigid-looking U symbol, sometimes like a squiggly E. The universal set contains all possible elements you are allowed to consider for that specific problem. It is the entire universe of your current game. And here is a fun twist. If you have a set A, but you want to talk about everything that is strictly outside of set A, you use a little apostrophe symbol next to it. We call this A prime, or the complement of A. So if the universal set is all 3D shapes and set P is just the prisms, then the complement, P prime, is literally all the 3D shapes that are not prisms. It's everything else in that specific universe. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are back. Welcome to Section 3, Visualizing with Venn Diagrams, the grammar of sets. We now have our vocabulary perfected. We know the command words, so let's introduce the grammar by visualizing these relationships using Venn diagrams. This is where the magic really happens and where we start applying our visual frameworks.
Let's contrast these 2 core operations. I want you to treat this as an interactive workshop. This is our first challenge, a 60-second visual data scan. First, look at the left side. We have the intersection. Remember our upside-down U symbol? P intersection Q. Visually, this is just the strict overlapping middle section of 2 circles in a Venn diagram. It's highly exclusive. It's only the elements that have the credentials to belong to both groups simultaneously. Now look at the right side. We have the union, X union Y, with the right side up U. Visually, this is the entire space covered by both circles combined. It's the big, inclusive party, where absolutely everything that belongs to either set X or set Y or both is invited. Understanding this visual difference, extracting this core trend, is the absolute key to mastering 0580 past papers. If you mix these up, you lose all your marks instantly.
Let's put some hard data to this. Challenge 2, find the flaw. I'm going to show you how a student would mess this up, and I want you to spot it. We have set P, which consists of multiples of 3, 6, 9, 12, 15, 18. And set Q consists of even numbers up to 12, 2, 4, 6, 8, 10, 12. If a question asks you for P intersection Q, Sam would rush this. He would just write down 3, 4, 6, 8, 9, 10. He'd just start combining them. That's the flaw. He missed the command word. The upside-down U means intersection. You have to act as a detective looking for the overlap. Scan the lists. The number 3? No, that's only in P. The number 4? No, only in Q. But look closely at 6 and 12. The intersection perfectly isolates 6 and 12 because they're the only elements brave enough to belong to both groups. If you were drawing a Venn diagram, 6 and 12 are the exact numbers you would write in that overlapping middle section. This is how you use evidence to back up your point.
We have finally arrived at Section 4, Solving Problems with Sets, the ultimate translation. Now for the climax of our explainer. Let's use our visual grammar to solve a mystery that looks complicated but is actually quite simple if you follow our blueprint.
All right, here is Challenge 3, Speed Writing. We are going to apply the Peel paragraph structure to a math equation. This is a classic Cambridge exam scenario. Let's read it together. In a class of 31 students, 22 study physics, 20 study chemistry, and 5 study neither. How many students take both subjects? This is exactly where students like Alex completely crash and burn. Alex looks at this, grabs his calculator, and says, okay, 22 plus 20 plus 5 equals 47. Wait, but the question says there are only 31 students in the class. The test is broken. I give up. Can you find the flaw in Alex's logic? I'll give you a hint. He is completely ignoring the intersection. He is committing the classic double counting fallacy. He's counting the students who take both subjects twice. So how do we correctly extract the core trend, find the overlap, and write a perfect mark-winning sequence?
By progressively breaking this down step by step using our set logic, we are going to transform a confusing word problem into a clean, simple algebraic equation. This is the mathematics success blueprint in action. Watch how Alex's red pen marks turn into beautiful green check marks. Step 1. We establish our universal set. We have our point. There are 31 students total. We know 5 study neither subject, so we place those 5 outside the Venn diagram circles entirely. That leaves us with exactly 26 students who must exist inside the physics or chemistry circles. 31 minus 5 is 26. Step 2. We need to find the intersection, the students doing both. We don't know it, so let's call it X. Step 3. This is the genius explanation move. If 22 students study physics in total, and X of them also study chemistry, then the students who study only physics is 22 minus X. Similarly, the students who study only chemistry is 20 minus X. So, our entire Venn diagram consists of 3 distinct parts that must add up to our 26 active students. The only physics students, which is bracket 22 minus X, plus the intersection, which is X, plus the only chemistry students, which is bracket 20 minus X. All of that equals 26. Step 4. We simplify the equation. The minus X and the plus X in the middle cancel each other out completely. We are left with 22 plus 20 minus X equals 26, which nicely simplifies to 42 minus X equals 26. If we solve for X, 42 minus 26, what do we get? And there is our link. There is our magic final answer right there. Exactly 16 students take both physics and chemistry. Do you see how incredibly powerful this strategy is? We took a massive paragraph of confusing text, we decoded the command structure, we translated it into a visual Venn diagram, and we used simple algebra to find the exact intersection. If you follow this 3-rule system, Rule 1, command word decoding. Rule 2, Peel framework application, mapping out your steps. And Rule 3, the time management matrix, meaning you don't panic and waste 10 minutes guessing numbers, but instead you just draw the diagram, you will guarantee top marks every single time. As we wrap up this explainer, I want to leave you with a slightly philosophical thought. Mathematics isn't just a bunch of numbers on paper. It's a structural way of viewing the whole world. Think about your own life today. What is the universal set you belong to? Your school? Your city? And when you think about your friends, your interests, your goals, who is standing right there in your intersection, sharing those exact same overlaps with you? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer videos. So here's your final reminder. Subscribe to our YouTube channel, AC Exams, at ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at ACExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below right now with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. Keep exploring the hidden logic of the world, and I will see you next time.